So, in today's session, we will start discussing Newton's law of motion. Before coming to Newton's law of motion, it was very essential for us to have a clear-cut concept about force and what is the characteristics of force. As we all know that force is basically either any kind of a push or a pull, right? We term it as a force. And unit of force is Newton, right? So the unit of force, which is Newton, is termed after a scientist, Sir Isaac Newton. And that scientist has given us 3 different laws associated with force. Those 4 laws are termed as Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion, right? So one by one we are going to discuss all of them. As we know that force is a vector quantity, that means it is having a magnitude and a direction, right? Any force will have a magnitude and it will have a direction. Clear? So keeping this thing in mind, we will try to understand Newton's law of motion. So let us first discuss Newton's first law of motion. First of all, we will go through the statement and then we will try to understand what it tried to predict or say. So according to Newton's first law of motion, a particle which is originally at rest or moving in a straight line with constant velocity, right? If it is at rest position or if it is moving in a straight line with constant velocity, it will tend to remain in the same state. Whether it is at the rest or it is moving in a straight line, it will remain in the same state until and unless the particle is subjected to any unbalanced forces. Clear? Until and unless the particle is subjected to unbalanced forces, it will remain in its own state, right? So if you can see here, we are having 2 different pictures. One, we are having a football which is kept on the ground and other football is having a motion. So a football which is kept on a ground, it will remain on a ground until and unless there is some external force or there is some unbalanced force experienced by this particular football. So an object at rest will remain at rest unless a net force act on it will remain same. Clear? And this is another football which is keeping into motion. So an object will keep on moving. That means this football will keep on moving unless there is some external force which will act opposite to it. Now, due to the gravitational force or due to inertial force, this football which is moving will try or will stop after some particular time, right? So this is what we are calling it as Newton's first law of motion. Unless and until there is some external force or there is some unbalanced force, the object will tend to remain in its own state as it is. Clear? So this was Newton's first law of motion. Now moving ahead to the Newton's second law of motion. So what do Newton's second law of motion states? Let's just see that a particle of mass m acted upon by an unbalanced forces F will experience acceleration A that has the same direction as the force and a magnitude that is directly proportional to the force. Clear? So what does this particular law says? That a particle which is having a mass m acted upon an unbalanced force F will experience an acceleration A that has the same direction as the force and magnitude and is directly proportional to the force. In simplest way, acceleration will depend on mass and acceleration will depend on the force. That means if to get more clarity on second law of motion, let us assume that we are having a cart and there is an empty cart. So the force which is applied to move an empty cart is lesser as compared to the force which is applied to move the cart which is completely filled with goods, right? So acceleration depends on mass and acceleration also depends on the force. That means according to Newton's second law of motion, force is directly proportional to mass, force is directly proportional to acceleration. Clear? So this is our Newton's second law of motion. How much amount of force we need to apply or we need to supply? It depends on the mass and acceleration of the given body. If mass is more, acceleration remain constant. If mass is increasing, then we need to increase the force. If acceleration is increasing, keeping the mass constant, force will be increased, right? So force is directly proportional to mass and acceleration. This is Newton's second law of motion, and this is very much important for us to remember that force is equivalent to mass into acceleration. Now moving ahead to the third one, which is Newton's third law of motion. This is again a very important law as we will encounter what Newton's third law states. So according to Newton's third law of motion, the mutual force of action and reaction between two particles are equal, opposite and collinear. Remember these three words: equal, opposite and collinear. Collinear means in the same line it will align, right? It will align in the same line, collinear, right? So according to Newton's third law of motion, the mutual force of action and reaction between two particles are always equal, opposite and collinear. That means according to Newton's third law of motion, forces always occur in pair, right? Forces always occur in pair, and those pair are equal in nature and are opposite in direction. Clear? Equal and opposite forces are there. For an example, if we shoot a gun, right? If we try to shoot, so once you shoot the bullet, the velocity with which bullet comes out of the gun is equivalent to the jerk which is exerted or which is experienced by the gun, right? The velocity with which this bullet is thrown out of the gun, the same amount of jerk will be experienced by the gun in backward direction. So this action is accelerating force of the bullet, and the reciprocal of it, that is the reaction of it, will be recoil force on the gun. If you have seen in movies or if you have seen that experience of how a bullet comes out of a gun, so you will always see once they shoot, the gun goes back in the backward direction or the gun moves in the backward direction, right? It will suffer some backward direction displacement. That displacement is due to the high velocity of bullet which is coming out of that particular gun, right? In the same way, if we are walking, floor pushes up and forward, right? Floor is being pushed in the upward direction and in the forward direction, and foot pushes down and in the backward direction. Once you walk, what you do is floor will be, we push the floor up and forward, right? We push the floor up and forward, and the foot will be pushes downward and in the back direction. And one more example if you want to take is, once you come out of the boat to the land. So what is happening is, if you will see in this picture, the boy is trying to come out of the boat in this particular place or land, right, or in this particular surface. So what will happen is, boy's feet will exert force on the boat. You will see when you will come out of the boat, boat will have a backward direction. It will be pushed in backward direction in the water, right? So the boy's feet exert force on boat, and boat will exert force on the feet. So these are all equal and opposite forces, right? So every action has equal and opposite reaction. So this is Newton's third law of motion, right? This is Newton's third law of motion. So let's just recall all the three laws of motion. According to Newton's first law of motion, any object which is either at rest or at motion in a straight line will remain in its state unless and until there is any unbalanced forces, or unless and until there is any external forces acting on that particular object. So this is Newton's first law of motion. Then comes Newton's second law of motion. It says that, or it states that, force is equals to mass into acceleration. That means force is directly proportional to mass and force is directly proportional to acceleration. More the mass, more amount of force we need to apply. More the acceleration, more amount of force we need to apply, right? And according to Newton's third law of motion, every action has equal and opposite reaction. Again, I am repeating, every action has equal and opposite reaction. Three words we need to remember for Newton's third law of motion, that is, it will be equal, it will be opposite, and it will be collinear. Collinear, it will lie in the same plane, lie in the same line, right? So I just hope all the three laws which we have covered today is quite clear to everyone, and I just hope everything which we have covered today is clear. Thank you.